Hello everyone, give me 1 second to get started here. Da, 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 da. Okay, so what I'm going to do today is a bit, shall we say, more challenging than what I did yesterday. Okay, and this is not meant for beginners per se. Well, it's not really meant for beginners to programming, but this might be approachable for people who have done some programming outside of C, for example. Yeah, but it's going to be a bit challenging for me. I'm not sure if I'm going to succeed in my task today, to be honest, but we've got these Leetcode problems. Now, I'm actually interested in something specific. Now, I may today or tomorrow or whenever do some of these easier ones. And I just made this Leetcode account. But I'm interested in stuff related to permutations right now. So I thought this was supposed to be hard. There's something else I was looking at that was hard, but I don't know. Let's look at permutations here. Is this the one? Oh god. Fine. Yes. Dragging tabs to preferred layouts. Yes. 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 Okay. Alright, this is different than what I was thinking of, actually. That's probably a good one. That's probably easier than what I was looking at. But I think if you can list out all the permutations, maybe it doesn't matter. There was a hard one I was looking at. Where is she? Okay, these are all the hard ones. I think it was permutation sequence was the one I was looking at. Yes. So I'm interested in this one. So let's make this bigger for people to see. The idea is that you're not just doing permutations, but there's an order of the permutations. And it's saying, so if n is 3, we're looking at all the permutations of order 3, meaning, all these right here, as an example. And it's asking to return the kth permutation sequence, where n and k are inputs to the function. So what is that, C++ there? We have the arguments of the function. I'm going to do C. And instead of doing things here, I was working on doing things in VS Code. And all I did so far is just made my own factorial function, which I'm sure I could have used the built-in standard library, but here is a factorial function. So I'll explain this briefly. It's a recursive function. One thing I learned the hard way with recursive functions, here's the recursive part. And so it calls the function again, so it loops back around. So if I give this a number like 6 or something, it's going to go through this loop probably, 5 times, I think. But if you have, be very careful. So you have this recursive part. You want to be very careful with anything you put after that. Or if you have recursive things in multiple parts of the function, it can get very confusing. By far, the simplest way to make a recursive function is you have the recursive part somewhere as close as possible to the end. So the only thing that happens, so anyway, so let's say the number 4 comes in here. And then also I'll explain this static int thing. It's like an int, but it sort of survives over the, well, it's, the scope is for this function. I'm going to be bad at explaining this, I guess. But this int, so normally a variable will be destroyed every time, or remade every time that the function is called. But this one stays alive. I guess for the life of the program, I guess. So it starts at 1. And then, so let's say we have the number 4 as input, for example. This times equal is just multiplying by n. So out will go from being 1 to being 4 in this example. We decrement n down to 3. And if n is greater than 1, which it is, we go through the loop again. So now n is 3. This already happened, so it doesn't happen again. That's the static part here. And then now n is 3, so now we multiply by 3, so we'll get 12. Decrement, so n is 2. Again, loops back around. Multiply by 2, so we get 24. Decrement to 1. Now n is not greater than 1, so it returns the thing. So it's a pretty simple little factorial thing. I'm going to need more coffee, so I'll be right back. So yeah, I think that's a nice little warm-up. I love this little factorial function. It's just cute. I like making it. So I did. And we're going to use it for the permutations. Because in factorial, if you want the permutations of n objects, there's n factorial many of them. So that's giving us a count of some kind. And I need that if I'm writing C code, because I need to use malloc. So we're going to use malloc, which allocates memory, because potentially the number of permutations could be very large. Well, it needs to be allocated dynamically. And let's see if I remember. I think that's right. I think this gives us the ability to use malloc. Look at that. It's got all these functions just like that. That's cool. I don't think it shows all of them. Huh, interesting. I don't know what's going on with that. Okay, so we want to test this. Also, let's just do a little search here. This thing is making me nervous. It seems okay so far. I've logged into the email here. You violate 87 dev. Email I set up for my channel or whatever. I never check it, so don't bother. Well, you can send me stuff a little bit, but what I don't like is that Chrome, all I did is sign into Gmail, which I didn't need to do. I thought I might need to do it to register for my Leetcode thing, but actually I don't think I needed to. But then it automatically logs you in here, right? Which means that potentially, let's say I were logged in on my phone, and I did searching on my phone, potentially that would appear here. That's fucked up. That is shit that nobody wanted, ever. Well, some people, I guess, like it, but Why the hell would I want that? So, let me log out of my email here. Stupid thing. Sign out. Okay, now we're good. I gotta have that as a habit. Okay, so what was I gonna search for? Okay. I always search like this: generating even permutations. I think I should find what I want. Down here, this website called qfbox.info has an algorithm. I like this algorithm because for reasons. They talk about it in here. But they enumerated. Well, I'm not gonna like say everything I could say about this. By the way, I forgot to mention, anyone watching this later, I did a live stream recently of an introduction to the C programming language, so you might want to check that out if C is totally new to you. I haven't set it up as a step-by-step tutorial, but I think that's a good start. It's kind of long, it's like an hour and a half, but it gives a lot of the context that you wouldn't normally get in a tutorial video, I think. And I think that's good, personally. And so it's a very light introduction instead of, diving in too deep. But so I guess if I were doing a tutorial series, that would be the first video, but I haven't made a second one. Everything else I've done has been kind of beyond that. What I wanted to say about this is that, let's see here. It says there do not appear to be any online resources that discuss how to enumerate all even permutations, or for that matter, all odd permutations. That's why I like this source. Now, I don't know about, I don't know when this was written, and maybe now there are other sources. But anyway, I don't, like, later at some point, I'm going to want to do even permutations and odd permutations, and most algorithms that you use are not, it's not going to be easy to make that jump. Well, it is easy to make that jump in a very inefficient way, so you can just do all the permutations and then check if they're even or odd. They talk about this here too. But that's kind of expensive to do and very inefficient. I would like to, so for example, if I need even permutations, I want to be able to enumerate them, generate them, without this in-between step of first doing all the permutations and then excluding the odd ones, if that makes sense. So, yeah. I'm choosing the algorithm with the future in mind here, that I want a certain algorithm. And it's not that bad. This is one of those things that takes a few readings maybe to make sense of. Use pen and paper, write it down, and figure out how this stuff is working. Hold on. It's getting cold. I need to get something to be warmer. Hold on. Be right back. 1 second. Got these little, I forget what you call these in English, warm pads or something. They have chemicals that interact with the oxygen. Or I don't know if it's the oxygen, but they interact with the air. And they get hot. Cool. And open on a sweater. Okay. So the other thing is this algorithm sort of starts, I think it goes in the kind of the opposite order. Let me see. Not that one. This one, permutation sequence. Maybe it's fine actually. No, I think it's the same order actually. Okay. So I'm going to continue to try to do this, to work on this. So I need to malloc some bytes based on oh, we'll see here. Hold on. This is awkward. Kind of awkward. Not gonna lie. Hold on. Okay. Try like that. Maybe I need to get like a fancy microphone arm or something. I don't know. So, all right, I'm going to make a separate function for this whole permutation thing like this. Cool beans. And let me do a quick sanity check with the terminal here. I think printf. What's going on here? Oh. Yeah, okay, the problem is here. Okay. So it's returning 24 for 4 factorial. That's good. Also, I want to do something with Git so that it's much faster. Git with date, Git commit with date. So this is a bad practice that I'm going to do, but I think I remember how to do it. Hold on. So git add all, I'm okay with that. Except I did it wrong. Git add 2 dashes, whatever. So we can do git commit, and I can push enter here, but I'm going to add the commit message here, so it'll get done in 1 line. And I believe I can go like, hold on. Oh god, this keyboard confuses me. Maybe I can do this. Uh-huh. 0. I don't know why it put 0 there. Huh. Sorry, this keyboard is still confusing me because I switched recently to Japanese one. The date is 0? What? I don't know what's going on with that. Anyway, it thinks the date is 0. It looks like. Whatever. So, the point is that I was able to do this in one line quickly. Saves time. And it's a very bad practice. But I don't care because I'm working alone here. Also, some shell stuff I want to do. Just, what is it called? Quality of life? QOL? Quality of life stuff? See if I remember how to do this stuff. There's probably... Can I figure out how to make the tilde on this keyboard? Alt? No. It's not this, is it? Oh, this one? No. Yeah, I'm confused how to do the tilde on this keyboard. It's a Japanese one. Well, I can just copy paste it. Copy paste. Okay. And I actually want all the information here. So I believe I can edit the .profile or bash RC. I think you're supposed to edit .profile though, for some reason, rather than the other one. Oh, no tilde. Okay, right click. Okay. So I'm gonna edit this .profile thing. And here it is, the default, whatever. So I'm gonna add some stuff here. Quality of life, so that things are faster. So alias, these are aliases, they're like shortcuts. So, and it's important that you don't have spaces here. This is gonna be my git add all. Using some Vim magic, we can copy a few of these. Let's do git diff. Okay. GC, I guess, for git commit. Yeah, let's do that. But I'm gonna make it this weird thing that I did. Git commit. Okay, now there's some weird stuff with the parentheses. I'm not sure. I think I can go like this. Hold on, let's see. I think this will work. Let me check it. Let's just open up main and I'll just add. Let's go to the end. Add a line at the end here. So if I do git diff, yeah. All right, so I wrote those aliases, but they're, if I closed this and opened up Ubuntu again, it would, basically the stuff in your profile, it just executes that stuff. So if you add an alias, for example, it will execute that and you'll have the alias. But if I want to avoid restarting the thing, I can do this source. I can source the file, will execute it here in the shell script, which is bash. So now if I do GA, it does what I set it up to do. I'm not sure that this git commit is going to work. Let's see. No, it doesn't like that. Git commit. Yeah, because this is not going to work, I guess. Hold on. Oh, I forgot the M. That's why. Okay. this M for commit message option thing, then it might work. I don't know. Also, there's a couple other things I like to add. Everybody does this in some way, shape, or form. But S is going to be source. Oh god, what happened? I think I pushed a button and changed it to Japanese or something. Okay. /profile. Okay. And alias, I use P for no particular reason. For this is gonna be edit for editing. Maybe I should use E. Let's use E. No, I've always used P. Who cares? Vim. Okay. So that's gonna be faster. Okay. But before I can use that, I need to source it the old school way. So now let's try this git commit here. It worked. Okay. Oh, and git log, of course. So now I'm going to do P. Sorry, E rather. I set it up for. And then git commit. Oh, I want one more, which is git log. I just hit S and it should source it. I can do GL for git log. Okay. So it's working the way I wanted. Of course, this is a pretty bad practice, but again, I'm working alone, so I'll do whatever I want because I'm alone here. Okay. So that was just some sanity checks, I guess. I guess you get 24. Good. Little quality of life stuff. It's always fun. Let me refill my coffee here. Can I reset the camera right now? Whoo! See if it lasts another 30 minutes. So apparently with the camera, I did a bunch of stuff to make it so I could use it like this. But even despite doing all that stuff, I think it stops after 30 minutes. And I think there's some technical reason about that if they don't have that, then legally it's a different kind of camera, a video camera, and it would have different taxes, blah, blah, blah. But there's some software you can use to get around it. What a pain in the ass. I think it will randomly stop. Well, I think it stops every 30 minutes. Just switches off. Hooray. Okay, so let's work on this thing. Get permutation. So in the beginning, it's fine to just output a bunch of permutations, but we're definitely going to need malloc. And the way we do this is we'll have, do we want to instar? This is going to be an array. I'm not sure. Let's see if they want an array or even just a string, maybe. Looks like they want a string. Well, in the see, why I like using C for these sometimes is that strings are basically arrays in C. So if you're doing like JavaScript, depending on whether you're doing stuff with strings or doing stuff with arrays, it's all a little bit different. So you have to memorize all this crap. It's not a big deal, to be honest. But I end up just Googling everything. With C, because strings basically are arrays, and arrays basically are just pointers, more or less. There might be I have to remember, I think there might be a very technical detail there, but all you really need are pointers. Most languages don't even have pointers. Anyway, So they want it as a string. So that's, well, I could have seen that right here. They want it as a string. Okay. So we'll work with this stuff as strings. And I like to have it like this. S for string is good enough. And here's where we need to use this. Of n. Now I'll just make sure. Sometimes I just compile things just to make sure that I didn't make a typo or something silly. Okay. Alright, so this should be the size that I have in mind. Let me think. The tricky thing here is that if we're doing more than 10, we need a little more space. But what is, let's say, 10 factorial? It's going to be a big number. But this is still, what is that, 3 million? 3 million. And let's say if we're using int or unsigned int, it might be, for example, 2 to the 31st power, I think. Yeah, it's way bigger. Dang, that's rough. Alright. I'll just malloc that times 2, which is gonna have a little bit of extra memory that we don't need. A little naughty. But it will get the job done here. Alright. And if I were doing this for something real, I'd probably add some checks, some sort of sanity checks, like, because if you try to do this for big numbers, it's going to crash. It's never, the factorial function's never going to get out. Actually, I guess, yeah. Actually, it's not going to be that bad. Let me think. The thing is that the output number will overflow at some point. So it'll become inaccurate at some point. Yeah, so anyway, I'm not going to worry about all that crap. Although, that's sort of the interesting stuff, but I think it will get too distracted. So, alright, we have some stuff malloced. And now I think I can actually work on the permutation algorithm itself. And I'm just thinking. But I'm going to assume that the numbers aren't too big in the start here. So I'm going to be thinking input is 3 or 4, something like that. I'm not going to worry about 10 until later. So in any case, this is not the one. I'm going to close that so I don't get confused. This is the one that we're working on. Permutations. Hooray. If anybody's watching, let me know if the mic is too loud or too close or anything. So, where do we begin? We'll start with the algorithm thing that I found before. So I'll try to walk through this mentally. But first, we want to start with it in order. So what we do is, let me think. And I'm going to have, okay. We're going to have something like a temp something. Maybe in the end we won't need it, but I want to be able to, I don't know. I want to be able to have a little bit of space to work with, if that makes sense. Okay. Because the first thing I want to do here is I want something that is going to look like this. For example, if it's 4, it'll be, well, it's a string, right? It's a string. Something like this if it were 4. So let's make some kind of iterator because we want to loop. So int I equals 0. Hello, Mr. Indian Gamer. Welcome. Number 001. How you doing? I'm going to guess you're from India. Actually, I remember you. Welcome back. You ever do any programming? So we're going to loop int I equals 0. Cool beans. Actually, let me think. We can do it the other way. This is fine. So we're gonna have like a while I is less than n, and then we're gonna have I plus plus and stuff here. This will iterate n times. Yeah, I remember you. I'm just worried somebody will come in at some point who has a very similar name but slightly different. I'm guessing there'll be like a Mrs. Indian Gamer that comes in at some point, and anyway, it's all good. So this will iterate n times. If this is confusing to anyone, just pick a small example like 3 or 4 or something and work through it mentally. We're going to do stuff here. Do stuff. And, I mean, this is a very common pattern that, with experience, people should recognize immediately. But anyway, so this will iterate n times. That's the idea. So, like, this is the same as saying, if I equals 1, and then this is less than or equal to, that would be the same. But programmers start with 0 when they count because we're cool like that. So anyway, so this temp thing, which is a string. Okay, but we can treat it as an array. That's going to be more useful. So I equals something like this, but let me think. We don't want to start with 1, or we don't want to start with 0, first of all. Also, is the order going to be wrong? No, the order is going to be fine. So if n is 4, this will, TMP will become 1, 2, 3, 4. Yeah. And that's why we start with 0, is because of the index for the array starts at 0. Because that's how programming languages work for whatever reason. Except unless you're doing Lua, then it starts at 1. And there might be other languages, but I don't know any of them. Alright. So, should I check this to make sure it makes some kind of sense? We can do a printf statement. So right now this is not returning anything. So temporarily I'm going to make this void, meaning there's no return. Doesn't return anything, just does some work. So that we can go here. I don't care about this right now. And so this gets called, and that's all that this function does right now. It returns 0. And so whatever happens here will happen. Good. Later I'm going to get rid of this because I'm hardcore like that. So I'm going to put it above here just as to help me remember that like it's not being used here. This will stay. I'm going to definitely need malloc. I can't get rid of that later. By the way, if anybody has any questions, just ask away. I know this is maybe complicated for people who are not experienced in these things. And, yeah. So we want to get this output somehow. Well, we're doing printf, so TMP. And this is a string. We print like that. I'll add a new line. My keyboard is confusing the heck out of me. There we go. Alright. And I'll try to run this. Too few arguments. Yes. That is true. We're gonna do 4. Let's do 5. And K is not being used right now, so whatever. Dun dun dun, question mark, question mark, question mark, question mark, question mark. Do 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 do. What the heck is going on? Because this is a something. It's not a char. We need oh god. We need what's it called? I2A or the other one, A2I. Okay, I think I2A is not that hard. So these exist out there, but I want to implement it myself. We're going hardcore in this series. How to coding? Yes. Have you done any coding? This stuff is a little hardcore, to be honest. Doing C programming. If you enjoy Roblox, I would recommend learning programming with that. Lua, that's a good start. Or JavaScript. The nice thing about learning JavaScript is that you can do stuff in the browser. So you can show your friends. And I mean, the nice thing is you get these like concrete results. Whereas I'm doing stuff in C here. So the output, you know, I run the program and I get the number 24, for example. If somebody knows for a fact that programming is for them, then starting with C is fine. It's actually good. But the thing is that starting with C puts a lot of people off. So it's sort of almost a mathematical exercise at this point. And I enjoy that. We got the factorial function, so yeah. But if you're new to programming, understanding this is going to be very hard if you're totally new. If you have 100 hours under your belt, then I could probably explain this. And it would make sense, I guess. What's my favorite anime? I don't really have one. There's a weird anime, so I'll mention an obscure one called Welcome to the NHK. I don't think I've seen the whole thing. But this anime is weird. I kind of like it. I want to watch it again. It's weird. Welcome to the NHK. So I'm not a huge anime guy. There's this other anime that I just can't remember the name to. That I kind of enjoyed. But like I can't even give descriptions of... I can't remember how to find it or anything. The people are in school. That's about all I remember. Let's look up popular anime. I doubt it's gonna come up. Oh, have you seen it? Welcome to the NHK? I thought it was pretty rare, but I don't know. Anime. Let's try to make this so that it's the right size for this format. Something like this. Yeah. So, see, I don't know any of these. Well, I know Naruto, but to be honest, I doubt that I'll be interested in Naruto. Death Note, I've definitely heard of. Apparently, One Piece, they're doing something new, so I kind of want to check out the new stuff. JoJo's, I've heard a lot of good things about. I've watched a little bit. I like it. Like, I would watch JoJo's. I just usually forget to watch it. Evangelion is really sort of classic, I guess. I like some of the music. Full Metal Alchemist sounds interesting. I don't know. Was there a game of that? What is all this shenanigans? I don't know. And of course, all the Ghibli stuff I like. Cowboy Bebop. I really like the music. I don't know. I haven't really watched it. Yeah, Dragon Ball. There's the new Dragon Ball, so my wife watches that. She likes it. She was a big fan of Toriyama. She was so sad when Toriyama passed away. I might watch some of the newer Dragon Ball stuff. I also have a French friend who really liked it. He was once a karate champion in Paris or France. I'm not sure which. But Attack on Titan looks cool. Oh, I love One Punch Man. And there's this other one called what's it called? Like Konami Can't Talk or something like that. I kind of enjoyed that. I'm sure I can find that. Anime Can't Talk. Oh yeah, it came up. Komi Can't Communicate. I enjoyed this one. I don't know if I watched all of it or not. I'm in Toyama. This is kind of a fun anime. Yeah, but I don't know that much, to be honest. I was in Tokyo probably 10 years, though. Okay. So, Malik. Right. Alright, so I need either the A2I or the I2A. I need I2A. Which means integer to char character. So, I probably want to implement that myself here. Oh, I don't have the GS. Hold on. Need another alias here. Right. Whatever. This time, wait. I remember something. This one's going to be GCD. Git commit with the date. Although the date is not working for some reason. And then alias GC is going to be just git commit. Okay. Because sometimes I do want to add the commit message. So here, I'm going to write permutations tochu, Japanese, and then what else? Going to implement I2A. Komi Can't Communicate. You've seen it? Yeah. It's good. I like it. I don't know if there were multiple seasons. I'm not sure. I'll watch it again at some point. Probably. Actually, that's a good idea, because I haven't... Lately, I've been watching House on Netflix. And I'm on almost to season 4. There's 8 seasons. So after I finish that, maybe anime would be nice. Help my Japanese further. So I'm going to implement I2A. And one of the things I can do should be... that's right. Okay, so I2A... Yeah. I believe I2A is not in the standard library because I2A has issues with it. I think the philosophy is rather than make some official I2A function that, or standard library function, whatever you want to call it, that rather than make something that sucks because it has all kinds of like weird unexpected results in certain edge cases, for example, rather than do that, they're just like, we're not going to have one. You're on your own. Roll your own. So I think that's actually a good idea, a good philosophy. So, yeah, so I'm going to implement my own here. Actually, this can get a little beefy, but I enjoy this kind of stuff. So let's create the file i2a, I'll call it uv i2a.c. But let's start by just implementing it here, I guess. Whatever. So, right, i2a has to return a string, right? So this is a string char star i2a int n. So what this does is it receives a number, an int, and it changes it to a string. Okay, this is going to be a bit beefy. There's a bit of meat in this thing, and I've implemented this before a couple times. So after I implement this, I'll check my previous implementations, maybe look online for some stuff. But this is a really good programming exercise. Not really beginner, but intermediate level, I guess. Actually, I implemented one before that has where you can input the base. You can do it in different bases, but we'll just do base 10 here. So I can do, I'm just going to write like really bad code or almost like pseudocode first. So for example, we do some checks like if n mod, actually let me think. Probably it's either mod or just divided by, for example, it'll probably be a big number first. So we want to figure out the range of int. I think it's this. This number here is like the upper limit, but it might be -1 or something. So let's see. Range of int. There it is, right there. Thanks, Google. So you'll notice the minus is 1 higher, because there's a value 0 takes up a little bit of space there. So this is the range for which we need to be able to be outputting a string. Whew, yeah, this is going to be gnarly, a little gnarly. This is going to be a brain workout. But, so for example, okay, here's what I'm going to do. So I'm not sure about the order. I'll just have to figure that out. But it's going to be easier to start with, just in terms of writing this out. And this is probably not the most efficient way either, but it works. This kind of thing. Until we get to somewhere around 2 billion, then I'll think about what it actually needs to look like. Is that right? So where are we at here? This number is 1 billion. I suspect we maybe don't have to go deeper than that. 1 billion. Cool beans. So let's think about this. So if n... okay. I'm going to be a little inefficient, and we'll have a char star s equals malloc. We'll just give it 10 bytes. 10? This would be 9, 10, 11 potentially. 11 bytes. So if it's divisible by... wait. This is supposed to be something equals... rather is greater than 0. So the division here with ints, it just rounds down, if I remember correctly. Yeah, I think it just rounds down. So like if n is 9, this should equal 0. But I might want to just double check that. That's how I remember it. Let's just do a good old, let's actually comment this out as well. Printf. I'll just do 9 divided by 10 here. And we'll output a decimal and a new line. Like, not like that. Like that. All right. So give me 0. And a little sanity check here. I love sanity checks. Just make sure it's doing what I think it's doing, and we get 1 there. Yeah, so it's like I thought. If in C this turns into 0, it rounds down. Unless you're doing floating point arithmetic. So actually, so if I did, just for people's reference purposes, these will be floats when you add the decimal. In fact, I think I can just do this. I always write it like that anyway. And we change this to F for float. And we can do that. And we get the float. A float is just a decimal number. F for float. Okay. Coolness. We don't need that anymore. So, like I said, if this is greater than 0, that means that n is more than 10. Or 10 or more. And in that case... oh gosh, it's got to go the other order, right? This gets complicated. Because the way I'm doing this, right, I have to actually check how long n is. Oh gosh. Just because I don't want the output to be like a string like this. We don't want that. So I need to first check the size of n. So we'll make a little function to do that. And it's actually basically the same as this, isn't it? Something like this. Of course, we're kind of ignoring the whole issue of negative numbers for now. We'll think about that later. It'll be okay. So it'll be easier to type this going from down here, maybe. I'm not sure. Actually, you can go like, I forget the shortcut. How do I do the multi-cursor in VS Code? Let's figure that out. Control Shift. Wait, what? I need it on Windows, brother. Windows. Why is it telling me this when I do that? Okay, Control Alt. Okay, Control Alt. It's not doing it. Control Shift. You still know how to do this. Control Tab? No, that would be dumb. Whatever, we don't care right now. The thing is, I do stuff on Mac, Linux, Windows, and different text editors and all this jazz. I forget. I forget all those shortcut thingies. We should be able to auto format this. Da-dee-da-dee-da. Selection. Is there an auto format button somewhere? I guess Google is my friend here. VS Code, auto format. Shift Alt F. Shift Alt F. Fail. Oh, good lord. Whatever. This is fun. This is peak programming right here. But what about negative numbers? Whew. Hooray! So it's basically a flag. So we check for if it's negative or not. Let me do our thing. Now I want to test it, because if you make mistakes like that, they will cascade. Or if there's a mistake in here. And D, new line. Comment out all the shenanigans. Now I might have left like silly code somewhere, and this isn't even running. Where are we? This was supposed to be void for now. I must have undone that earlier. So we should get it as output 4, unless I've made some weird mistake. 1. So 3. Da-dee-da. Wait a second. I think the order needs to be reversed here. Yeah, because you could have a number like 300. Wait. No, that would still... I think I need to reverse the inequality. Sorry, hold on. Yeah. Well, it's if it equals 0, actually. 4. Seems to be working. All right. So we're getting the size of the number. It's really the size of the string that we want. Anywho. We're going to malloc the size here. Coolness. Actually, I think it's going to be kind of similar stuff to this. But what I'm going to do, I'm going to make some kind of index. So int index. And so if n is less than 0, let me pour some ice and coffee or something. 1 second. I don't have ice right now. Dang it. Hooray! It's programming! It's theoretically fun. It's kind of fun. I didn't anticipate needing itwa. I like when people call it itwa. Fun stuff. Do 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 do. Alrighty then. I love this stuff, actually, to be honest. Alright. Why not be honest all the time? Well, we can't. But S index... Yeah. We need to do a little more than that, because we need to increment the index. Hooray. Alright, we have this size thing. So what are we going to do? I don't think we need to do this. We have like, we have a power function. Let's implement our own power function. Building from scratch. So, uvpow. It's going to take, what are we going to call it? Int something and int something. Pow for power. What do you call the thing that's being powered? Let's just call it n and the exp. Let's do that. So, what is this going to look like? So we're going to be recursive. I want it recursive, yeah. Jeez. I don't know. Let's do a static int out equals 0. If n equals 0, return out now. Why didn't I just return 0? Because this is going to loop. In general, this is going to loop a bunch of times, and at the end, n will be 0. We'll see how this works out. So let's pretend n is 3 and exp is 4, I don't know, 4, I guess. So out will be 0. The first thing we need to do, we need to get out to be equal to n to start with, I think. Sorry, if exp if exp is 0. But that's wrong. That's wrong. If n is 0. If exp is 0, usually it's going to be 1. So I think 0 to the 0th power is 1. Yeah. Anything to the 0th power is 1. So I'm thinking a little too much about the edge case where exp is 0 to begin with, but so let's say exp is 4, for instance. First of all, we need in the beginning for out. Dang, out has to equal n at some point. When do we do that? How do we do that? How do we do that? This is wrong when exp is 0. We need to check exp first. And then as we iterate here, we need to never allow exp to become 0 when we're cycling through. As soon as exp is 1, we need to return out. Can we? Okay, let's make it n to start. There we go. And so if exp, before this, we check if exp is 1, return out. So if the input is that exp is 1, and we get any kind of n, it is going to return the n, which is what we want. If exp were 0, it's going to return 1, which is what we want. So now n has to be greater than. We're not going to count negative exponents. We don't care about that today. So by the time we get here, n must be greater than 1. So I think we can just do out times equals n and decrement n. And then if we're going to check for if n is 1 here, or exp is 1 here. I should be decrementing exp rather. So we're going to check for this below. If exp equals 1, return out. Else this is where it's going to iterate, or recursively iterate. And it's going to be still n and exp. Alright, so exp is getting decremented. This might work or as it is. This might be finished, but I need to test it. Just walking through in my head to check. Wait. The order's wrong. Okay. This check needs to happen before we multiply. And then... okay. I think now it might be okay. For the general number, in the last iteration, it will come through here where exp is 1. It'll check this, it'll skip it, check here, and then it'll return. If exp is greater than 1, it will multiply, it will decrement exp, and then it will go through another iteration. So this might be working. Okay. I just want to test that. Power function. Oh my god, we're using... It's fine actually. I should name this my own thing though. It's not a built-in function, so it didn't have an error, but this is better. But I'm not going to do that right now. So we're going to print out... let's just start with 2 to the 3rd power. Interesting. You're not allowed to do that? Are you not allowed to do that? What? Has to be constant, huh? I didn't know that. Okay. Dang. So what are we gonna do here? We'll just have a static int. Static n equals wait, I'm just no, I'm doing something that doesn't make any sense. We got a little bit of a problem. What are we gonna do? I am not allowed to do this. This is not good. What are we gonna do? Suppose we're not doing this at all. And we just do like static int out equals, let's suppose we just do 0. But it has to... Okay, I think I can have a static int that is like a count, iterator count. Okay. And let's start at 1 for our sanity. And so if the exponent is 1. So if iter equals 1 and x was on, then we're going to return n. We need to increment the iter thing. We still have this problem. Something like this. If iter equals 1, so only on the first time, out will be set to n. I don't know why you can't do this equals n thing, but whatever. So that will happen only the first time. Maybe it's okay now. It seems needlessly complicated. Out times equals n. So we'll see. Maybe this works. I feel like there's a fair chance there's a bug in here. When 2 to the 3rd it became 8. That's good. That's a good sign. Let's do 3 to the 4th. I think that should be 81. And if this is right, good chance that we're good. Let's check some weird edge cases, like 0 squared. Little edge case testing. Good. And anything to the 0th power is 1. 0 to the 0th power is 1. Good. That seems to work. So I'm going to commit. Normally you're supposed to use the present tense for commit messages, but Did pow function for iter, itwa function. We are doing Doggen for permutation function. Hooray. Should I actually set up like a GitLab? It's getting to that level with the work, but I'll just do that off camera next time. Although people following along might end up being interested in how to set this stuff up. Free trial. I'd like to start an account, not a free trial. Of course, I could use GitHub. I don't trust Microsoft. Do not trust Microsoft at all. I signed out of the email account. I'm going to sign back into the email account off screen here. So the purpose of, so Git, there's a lot of confusion for people starting off with Git. And I'm just going to click on the Google thing here and try to do authentication there. Click on my email, continue. Verification code, okay. Just doing the verification code. Should be good to go. I'm gonna log out of my email. Good. Okay, so here's Git Lab. So there's a lot of confusion with beginners. So let's see here. I have these are aliases. You don't need to worry too much. They're like shortcuts that I've made for myself in the terminal. And you can see some of these are Git things. There's really no way around it that learning Git is really confusing in the beginning. But I recommend starting with your projects using Git. I mean, not from the very beginning, but and like typically people are not using Git, say like with Roblox. And if you're doing something heavy duty like Unity, I don't know what people are doing there, because anytime you have, if you're working on a game, for example, and you have big files, we don't use normal version control with big files, with images and stuff like that typically. So a game would have a lot of images, and if it's small, you could use Git, but you'll run into problems eventually. It'll be unwieldy. So that's another sort of thing to think about. But anyway, so if you're doing some coding projects that are mainly text, because code is mainly text, and if you don't have a bunch of images and stuff, that's a perfect opportunity to start using Git. I'd recommend using it just on your system, just locally at first, meaning just on your computer, which is what I've been doing so far. But now it's starting to be a bit of work, and if I lost all this data, if this computer just became a brick tomorrow, I'd be really annoyed that I lost all this progress that I've been doing. So at that point is when I'll put it into the cloud, which the cloud is just someone else's computer. Yeah, so typically that's going to be GitHub or GitLab or something. Those are just websites. So again, people get really confused. What's the difference between Git and GitHub? GitHub is a website, period. Forget about it for a second. Git is a tool that is typically run in the terminal. It's a command line tool. Though people build software on top of it where you can get a GUI to work with it. Anyway, so in the beginning, you should probably, if you're new to Git, again, give it time, maybe a month or two at least, where you're just on your local system. You're not getting confused with GitHub and GitLab and that kind of stuff. Just use Git locally for a while and go through some tutorials. They'll teach you what you need to know. These are the main commands, minus this one. This one, forget about that one. These other ones are commands that you need to learn. And that's, I mean, using just these commands, you'll be good for a few months. There's another thing, another thing I should say about Git that was confusing. It messed me up in the beginning. Oh yeah, I'm in the terminal. If I do a Git status, or sorry, if I do a Git log, did I commit, by the way? Yeah, we committed. Okay, if I do a Git log, this gives me like the history basically. So the first commit, a commit is like saving your progress. So this was the beginning with main.c, and this I worked on some code to check if a character, individual character, is a numerical digit or not. That was the first thing I did. So these are my notes saying stuff I did at certain commits. You know, notice that it has a timestamp and all that good stuff. I got lazy with the commit messages at some point, so I did this. That's a bad practice. But I'm working by myself here, so I really don't give a F. But I'm just crazy. This is the most recent thing I did, where I just did a commit message, did POW function. Yeah, we're kind of getting a little bit deep in the layers here. We're trying to do some permutation stuff. But I kind of, rather than using a lot of the standard library stuff, I'm rolling my own solutions for some stuff. Well, E2A I think is not in the standard library, but I could easily find it online. Some kind of implementation for it. And I did my own power function because I'm a masochist, but it's a good exercise. And what was I going to say? So you can actually sort of revert the state. Like, say I want to go back and see what things were like here. So let's just demonstrate that, how that works. So I'm going to copy. I can press Q to exit that little log thing. You might want to do a git status just to make sure nothing crazy is going on. And git checkout, and then paste in that. This is called a hash. Okay, so I'm going to check it out. Hey, Koi Fish, how's it going? We're teaching some programming stuff, I guess. How you doing? So I've checked this out. So it says, switching to this hash, you're in detached head state. You can look around, make experimental changes and commit them, and you can discard any commits you make in this state without impacting any branches by switching back to a branch. If you want to create a new branch to retain commits you create, you may do so now or later by using -c with the switch command, and they give some examples. So I got used to seeing this a lot and started sort of ignoring this in the past, and that caused me a lot of problems. This is actually really important information. So the thing is that, suppose I've gone, like, I'm working on some stuff and I make some mistakes and I go down a path that I regret, and then I want to revert back. First of all, it's much simpler to not revert back and to just keep going. Just get rid of the stuff you don't need, change it and fix it. But it's going to happen eventually that you want to go back. I just wanted to say hello. I was about to sleep. I just got out of work. Oh, okay, nice. Thanks for checking in. Thanks for saying hi. So, and sleep well. Yeah, so there's going to be a time when you want to just go back to somewhere and then, like, sort of diverge from there. Use that as a starting point. And if you do that, you should make a new branch and learn how to use branches with Git. Because what's not going to work, let's say I go back here, I start from here, and I start making changes. That's what it was talking about with the detached head state. If you start making changes here, you can't just commit them back onto this master or main branch. You can make a branch and then, start branching off into, it's like the multiverse, and you have different timelines. You've created a parallel universe and you're branching off. It's like a tree structure. You can do that, but you need to make a new branch. Don't start building from here. And by the way, time is going up. This is the most recent at the top. Don't start building off of the previous commit and think that it's like, what's the word? Overruling? No. Overriding this other stuff. If you don't make a new branch, it makes no sense to start building off of a previous commit. Basically, you need to make a new branch in that case. So just remember that. And this can get a little bit complicated. And like I said, Git is not easy. It's a bit of a steep learning curve, especially when things go wrong, especially when you have multiple branches, especially if you're collaborating with other people. It's mainly when things go wrong. which is going to happen. And you have git merges are complicated in the beginning, at least. And yeah, git is going to be a nightmare at some point for you if you're going to have a career in this stuff. It will be at some point, but that challenge is just an obstacle you'll overcome and you'll become stronger. So going back to what I was talking about, in the beginning, you want to use these git commands, do some tutorials, work locally for a few months, and get comfortable with that. You'll probably mess up at some point. Again, try to remember what I was just saying about checking out previous commits, and if you're going to work from there, you really need to make a new branch. And yeah, like anything, there's just a learning curve, and don't think that it's going to be easy. Think that it's going to be challenging, and but get the hang of it for a few months, and then do something like GitLab or GitHub. There might be new ones that I'm not aware of yet. There's a bunch of websites where you can basically commit remotely. So everything so far has been on my local machine. That's cool, but I want like a backup. So we're signing up for Git here. Because I want to store my code. I don't need to do any of these. Who will be using GitLab? Just me. Continue. Oh. Create a new project. Okay, fine. Continue. I don't want to jump right into this, but it's forcing me to do it. Okay, so we're creating... So actually, let's see here. The project already exists, right? Whatever, I really don't care. I'm going to delete this later. So let's just blah, blah, blah. There you go, GitLab. Yes, yes, yes. Congratulations on creating your project. No, I'm not going to invite anyone. No. Okay, so here we are in GitLab. So I'm going to hit plus. And probably new project. Slash. We call these repos. I'm going to do imports. Let's see if that's going to work. If it's going to be simple. There's probably a lot of complicated options. No, I'm going to do create blank project. Anyway, let's walk through this. So we'll call it that, UVC. I don't care about the URL, project slug, whatever. I just want to get things going done as quickly as possible. I don't want all this crap. Okay, this is optional, so I'm not going to do that. Now, private, what I'm working on is pretty public, so I'll do public, but be aware of this. You might want to be private, especially if you're doing any web stuff and you have like tokens and things. Be extremely careful. There are people, there are bots automatically searching public repos for tokens, credentials, all that kind of stuff. So I would recommend if you don't know what you're doing and you're doing any web stuff, I would recommend just being private. The only reason I'm making this public is maybe people will want to see it. So whatever, we can make it public. Initialize repository with a README. I'm going to do no. I can always add a README. So we'll create the project. Okay, hopefully this is not going to be too complicated. I don't mind. This is not a bad idea. Let's do this. Right-clicking to paste that in. Okay, cool. This is pretty optional. Because you would have done this the first time you used Git. Now about adding files. So this is starting from scratch, basically, but we already have an existing Git repo because we've been working with Git. And so I actually want to explain what these commands do, because it's much better if you understand what commands are rather than blindly. I mean, if you make it a habit of blindly running commands that you find online, of course, I can trust this website with that. I have that level of trust for this website that I could just paste this. But, I mean, there could be, like, weird exceptions. Like, here, I mean, this is not... You're going to have to fill in information here. So it's better just to read it and understand what the heck is going on. So cd existing repo. We're not going to need that. We're already in the directory. This stuff is probably okay. I mean, I really doubt that this is going to be necessary, but we'll just do it. And hopefully this is going to be okay. I probably have some business with keys. This is we're probably going to get an error, I expect. But so I'm going to right click. So are you sure you want to? Yeah. Okay, so there's some issues. So what we're trying to do is take all the code we've done so far and push it onto this remote website. Now, in general, we want that whole thing to be encrypted, right? Now, in this case, the repo is public, so really it doesn't matter. So really, they could have just done this using like plain text over the interwebs. But in general, that's not how they work. In general, this is going to be encrypted. So there's some stuff that has to be done for the encryption, and hopefully this is not going to involve a lot of work on our part. But let's take a look here. Operation not permitted. So it said we've got a problem here because nothing's encrypted. The authenticity of the host cannot be established. Give some key fingerprint. So I'm going to say yes, first of all. So this is basically saying, this is Linux speaking here and saying, do you want to trust this host, gitlab.com? So we're going to trust them. We're still going to have problems, I think, but because we haven't done anything related to any kind of key. So if you don't know what I'm talking about with a key, when you send encrypted data over the internet, there are public and private keys involved. This is like just standard basic encryption information. So we've added it to the known host, so we can, so we're saying that we kind of trust them. But we're having issues with blah, blah, blah. We're having some issues, right? Okay. So let's see if I remember what to do here. First of all, I'm curious about my keys. So you see I'm in the C directory. So I'm going to just do CD to be in my home directory. I'm going to do ls like that with those options. And there's a .ssh thing. So this encrypted traffic works over SSH. I'm going to see the SSH is secure shell. It's just kind of the technology that's used. I'm going to do it with the options here. Okay, so we have known hosts. So what I noticed is we don't have any keys here. So we're going to need to generate keys and stuff like that. Coolness. So I'm going to go back, I need to go back to, let's see, let's try settings. We need to set up some keys or something. Access tokens. Okay, group settings. I'll just call it UV. I don't care about the description. Private. This is going to be private, so that random people on the internet who get my keys cannot mess with things. Advanced. Yeah, I don't know. Let's just save changes, see what happens. So we have a group. I'm not sure if this is what I wanted. I don't. Yeah, I don't. Maybe we need a group for what we want to do, but I'm not sure if that was necessary. Access tokens. Let's click there. So I want to create an access token somehow. All right, let's use Google. So I'll just do GitLab SSH. Should be okay. Use SSH keys to communicate with GitLab. Actually, I like this Japanese website because they're very to the point sometimes. Yeah, here's the key gen command I'm gonna want. But here's a lot of general knowledge. Understanding some basic information about SSH and keys is probably a good idea if you're interested in being a programmer. Okay, all the way down here to generate an SSH key pair. I'm just going to use two sources here. We've got this one here. This is probably fine. Let me check the options. What's the T option? Is a type. So I think this might be a good. So there's older. So there's different ways to do encryption. There's older methods that are not good anymore. So you actually do need to use common sense. So using my common sense, I'm going to Google if this is good enough. Is it still good? The NIST speculates they'll be good to 2030. That's actually not so great, to be honest. Can I use better encryption here? Because I could totally see myself forgetting about this stuff and then somebody hacking it in 2030. That would be bad. So let's see. 2048. So can I do 40? What's the other one? 4096. I don't need a comment, so I'm leaving out the C option here. And I'm going to... Now, it doesn't matter where you do this command. Hold on. The SSH keygen will do this in this directory. It doesn't matter where you are on your system. I'm pretty sure. So let's try to change this to 4096. Seems to be working. Enter file. So there's a default file. That's fine. Enter. A passphrase will further add to the encryption. So I will add a little passphrase. Just makes things a little safer. Okay. This you can ignore. But the point is, now if I do an ls here, we have a public key and a private key. Camera died. So I can show you guys, I can show the world the public key. There's my public key. The world can have that. Doesn't matter. That's the point of being a public key. But I don't want to show everyone the private key. So I'm not going to explain how encryption works with the public keys and private keys. I forget, what is it called? Maybe it's called two-key encryption or something. But that's actually really good stuff to learn. It's very interesting, but it's sort of out of the scope here today. Just know that... Maybe I'll really quickly try to explain it. I'll really, really briefly try to explain it. The point is that we have a reversible... Sorry. if you need, first of all, you need a process that is easy to do but difficult to reverse. So what they probably do, they have some kind of mathematics involving large prime numbers, and I can give you a large prime number, and it takes a really long time. I mean like really long, like a prime number that's like 100 digits or something, like really long. And I generated, wait, no, forget about prime number, just a number, a really big number. And I'm aware of the prime factorization of that number because I generated the number using that information. So it's actually, it's like a bunch of prime numbers, 17 times 19 times blah, blah. And actually, no, okay, I think they use big prime numbers to generate a larger number for this. So the point is that I can give you a number that's very big, and I know the prime factorization of it, but it would be very hard to calculate the prime factorization of it. Nobody else can calculate that in any reasonable amount of time. It would take like the age of the universe using current computing power, something like that. So the point is, the prime factorization is my private information, the key, the private key, I think. And the big number is public information. So what it creates is this method by which it's like mixing two colors together. Once you've mixed two colors, I can tell you the result color, but it's hard for you to guess what the original colors were that I used to make that composite color. It's like that. And so it's very easy to, if you know the two colors that you want to mix, if I told you the private information, you could very easily mix those colors. So it's easy to go forward with this process, but reversing the process, going from the composite color back to the original colors, that's almost impossible. You see, so there's like public information and private information. And we do this sort of handshake where, we both have public keys and private keys based on all this stuff that I just said. And then we do a thing where, so let's say it's me and it's GitLab. I will take GitLab's, and we'll use the color analogy. I'll use GitLab's public key. That's a color. I'll mix it with my private key to make a composite color. And then I'll send GitLab that information. And then they will take that composite color, mix it with their own private key, and then send me that composite information, composite color, for example. And now somehow we have a shared key. I forget exactly the details, but it's something like that, and it's really cool and worth learning at some point. Anyway, so we have a private key and a public key. That's the important takeaway. Cool beans. So we've generated this pair. Luckily, I've done it with the better encryption method. RSA 4096, which will hopefully last a long time. So again, I just want to reiterate, it was good to use common sense. I don't know what this thing is. Maybe this is an old... Hopefully they wouldn't have old information here, but if I had used this one, it would only be good to 2030. 2030 is not that long from now. It's 6 years from now. Could definitely imagine myself not remembering to update anything. So that could be dangerous. Now, I think what would happen is just that they stop allowing, once these keys become insecure, they would stop allowing people to use it, or they would stop accepting those kinds of keys. So I don't think I'd actually run into any real problems, to be honest, but whatever. Better safe than sorry. So blah, blah, blah. So it's telling us how to do, we already did this stuff. Passphrase. Okay, so configure SSH to point to a different directory. I don't know about that. We don't need to do that. I'm happy with the SSH being the one. This is how to update your passphrase if you want to. I mean, it's when you're actively working with this kind of stuff, it's good. You'll end up doing this a bunch of times, which is a good thing. and then you'll get in the habit of it. You don't need to yeah, you'll learn how to make new keys quickly. That might take some time, but it'll be good. Upgrade your RSA key pair to a more secure front. Yeah, these are things that I don't need to do. Blah, 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 a bunch of things I don't need to do. Actually, let's use this other source now. It says add to your... this is too much information, frankly. Blah, blah, blah. Touch config. Okay, so I need to give my key to GitLab. How can I add a key? How can we add a key? And by the way, if you're just a beginner programmer and you don't want to mess with all this crap, you could just use pastebin, set up a pastebin, or just email yourself your code, zip it and email it. But it's kind of better to bite the bullet and do something with Git and to use Git with remote repositories, which is what we're doing now. It's better to do that because you can very quickly from the command line do this stuff and make it a regular habit, so you don't end up losing all your code, your data at some point. That would be nice. Now, GitHub was a little bit easier to set these things up, to be honest. Anyway, group. I just need to add a key here. So let's see. GitLab add key. Just don't like, I hate all this information that pops up. GitLab add key. Here, this will be faster to get the information. So click on settings. It used to be a little easier. SSH keys. I'm going to scroll down because it might have changed. This was from 2019. Profile settings, keys. Yes. Maybe this. Huh. It's kind of a little more complicated than it used to be. Anyway, settings. Should be access tokens. Should be this. But how do I add an access token? Okay, you can enable group access token creation and group settings. Oh, I haven't enabled it, maybe. To be honest, GitLab, this is a complaint with GitLab. Their UX sucks, in my opinion. This is not the first time. Like, it shouldn't be that complicated. Blah, 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 man. Jeebus. Jeebus. Alright, I'm gonna suck it up and go back to GitLab's information here. Oh, jeez. It says git bash on Windows. Right, so this is just going to... all this is doing is putting my public key in my clipboard is what the idea here. So, yeah, so I'm going to copy this. That's all they're doing. It's my public key. I believe in WSL it's Control-Shift-C, probably. Okay, sign into GitLab, edit profile, SSH keys. Okay. Oh god, the UX is crap, honestly. Edit profile? This is such a... See, the UX... This is terrible UX. It should have been like, when I made the project, it should be really straightforward. Like, hey, do you want to add a token or add a key or something? And where do we go? My pronouns, yay. It's probably not even up to date. Jesus Christ. If only GitHub were not owned by Microsoft. Okay. Edit profile on the left sidebar, select SSH keys. So if there's no SSH keys, then it's obviously out of date. Freaking GitLab. Let's see. So I need to maximize this for a second. Okay. That's why I wasn't seeing it, because the thing was too small. On the left here is SSH keys. So that's the thing. Yeah, that little sidebar hides. That's why. That's why I wasn't seeing it. But that's a UX thing. Anyway, whatever. Now we've got this going on. Add new key. Here's my key. I'm going to paste that. This doesn't matter, the title. Blah, blah, blah. This is publicly visible. I don't know if it matters. Let's just call it UV. Screw it. Expiration date. I want this to be as late as possible. Really late. I hate having to redo these. How late will you let us go, GitLab? May 1st. So it's possible that we'll be able to push to the remote repository now. It's possible. So it's this command was the one they gave me from earlier. This was the last command. I'll hit enter. Hooray. Okay, this one, the command before that. Oh yeah, I'm not in the right directory, of course. So now we're trying. So my passphrase for the key. Looks like it's working. Yeah, that worked. So now the code should be available. So that wouldn't have been so bad if this screen had been, you know, I have this screen small because we're doing vertical format. If it had been bigger, it would have been easy to see this SSH keys. So adding this key is not that hard once you know, once you don't make silly mistakes. Yeah. And all right, let's go back to the project. Let's just make sure that the code is there. We've got all our code here. So if my computer disappears for some reason, I've got the code. That's a thing. That's a good thing. Yeah. I know this is a pain for people starting out. But this content is not really meant for people starting out, to be honest. Let's do a git status. Yeah. Remember I was showing how to... I was talking about checking out previous commits. So I want to go back to master. I might be able to do git checkout. Is it master or main? That might be good enough. Git status. Yeah, we're up to date. I want to make sure this is the last commit here. Yeah, it is. That's the most recent commit. So it didn't matter that I was checked out onto some detached state or whatever. It still worked correctly. All right, I'm going to use the restroom. I'll be right back. Hello, how's it going? Carmen, good morning, how you doing? Is anyone still there? Because it will affect what I do here. It's been more than 2 hours now on this stream. It's a little cold. I think I'll be okay. 18 degrees in this room, it says, in Celsius. So a little recap, what we've done so far on this channel with the C programming language. Let's see, this is the second, it's the third stream. The first stream was vertical format, second was horizontal, but it was an introduction to C. The C programming language. And this is the third stream. So the middle one, the second one, was horizontal format. And I recorded it so that I'll probably package it as a video on my channel at some point. Maybe unedited. Maybe edited, I'm not sure. Yeah, so I'm not going to go through all the details, but in that second one, I do talk about how to navigate in the terminal. Not strictly required for doing C, but if you program in C and you don't know how to use a terminal, that's bizarre. Everybody knows how to, everyone who does C to any normal level of proficiency is pretty much guaranteed to know how to know their way around a terminal, I would imagine. Well, there's probably some Windows developers who actually aren't comfortable in a terminal, but it's weird to me. I would highly recommend learning your way around a terminal. So I talk about that in the previous stream. And yeah. So we worked on this isDigit function, which takes a character, a char, and tells you if it's a number, essentially. Hooray. That was the first thing that I did. And then today, significant step up, because I'm trying to do this Leetcode permutations challenge thing right here. But I'm sort of relying on the standard library as little as possible, so I'm implementing a lot of my own functions. So somewhere we have a factorial function, way up here, I guess. Here's my own factorial function that I did this off camera, but I explained this actually at the beginning of this live stream today. Then this is just incomplete because I'm trying to do my own eToa function, which eToa is int to alphabet, essentially. So it should take an int and output a string. Right now, this is the wrong type for the function, but that's because it just makes it easier to build up in the beginning. Later I'll correct that, of course. And I needed this thing that tells us kind of the size of the integer, yeah, from a standpoint as a string, basically. So that's up here. And I thought I might need a power function, so I implemented that. Like the factorial function, this is a recursive function. This looks a little weird to me, I'm not sure. I'll look at previous implementations I've done and maybe just Google some implementations and You should be able to do this more elegantly than what I did here today. It's a bit exhausting, so I'm debating. I think this is a good place to pause, I guess. What's the git status here? Okay. But I'm debating whether to restart the stream and continue. Or, I'm not sure. I might continue. And I might have done enough for today, maybe. I'm not sure. But I need a longer break, I think. And yeah, it's very much... This is probably going to take at least another... If this goes really fast, another 20 minutes. But it could take an hour or two. Potentially. And... it's a bit overkill. We could have just done... Let me think. We could have just manually hard-coded this information for like the first 10 results. That actually would be faster as well. So I don't even really need this E2A. It's legitimately faster. Hold on, where is that? It's legitimately going to be faster to just say, like, if n equals 3, we start with 1, 2, 3. If n equals 4, start with 1, 2, 3, 4. That's actually going to be much cheaper in terms of resources, even though it feels not like the programmer way to do things. But yeah, now that I'm thinking about it, that will be much cheaper in terms of resources. Makes me feel kind of stupid, but I think it's good that we're doing the E2A. I wanted to do this E2A, I2A thing anyway, so I went down that. I went in that direction. Yeah, this is cheaper. It's cheaper, but somebody looking at my code might think, wow, this person chose a dumb way of doing this. Anyway, I think I prefer the less expensive way. So we're going to need parentheses. And it will be, let's see. In fact, we could have some string that just is this. We're probably not going to do more than like 9, because 9, well, it's hard to say. 9 factorial is still in a decent range here. At what time does this become unwieldy? Yeah, already at 13. It gets pretty big. That's going to be bigger than the int size. So I think we only have to do it up to 12. But having stuff like, having this then be 8, 9, 10, 11, 12 is a little awkward, no? Let's see, do they say up to 9 or something? Discussion. What's LTE? Just generate the kth permutation directly. Oh, I'm not sure. I'm gonna skip over that. Also, I'm using a specific algorithm that I wanted to implement. But if I thought about it, I'm sure I could make an algorithm that's easier to do. So that's another thing I could choose from different algorithms. But the algorithm I was planning to implement has more long-term value for me. I'm just curious, like, what the biggest... TLE, what is... What is LTE or TLE? Something time exceeded? LTE is something time exceeded, maybe? TLE? Time limit exceeded, okay. Yeah. Well, I can see how a lot of people are going to get time limit exceeded for this if they, depending on what kind of algorithm they use, I think. Maybe it just goes up to 9. Oh, backtracking. Permutation swap logic. Well, I think, gosh, I might just assume that they go up to 9 in the beginning and see if I pass all the test cases. And then I'll think about if I should do more or what I should do. Anyway, let's do up through 9. Be quite a lot of different permutations anyway. So we start with something like this and we just cut it off, depending. So if n is 3, it gets cut off here. If n is 4, cut off here. Anyway, I don't think... Why is there a... So this is a debug, a breakpoint, which I got by accidentally clicking here. So I'm just going to click there. Anyway, this is garbage code. Yeah, I think I need to work on this again tomorrow when I have my coffee, my beginning coffee, starting the day. Because I'm a little mentally exhausted. Just gonna get rid of the scrap. watching the dot up here will tell me when I'm back to where I last saved. And there. Okay. Anyway, I could have just closed out and not saved. So I think that's it for today. It was a good little session. Hello, futile lads. What's GS? Let me check how many people are watching right now. Not too many, huh? Got 3 likes. Thanks for the likes, everybody. Helps out a lot. Yeah. Just joined and I'm leaving. I am a little tired. Plus, I just finished explaining everything that I've done recently, so we could do some basic, easy versions of this, but let's go to problems. I think I need a break. It's been 2.5 hours. But I just made this Leetcode account today, so I could do some easy ones. Yeah, but I think I'm done for today. So thanks for joining. Everybody, I hope you have a fantastic rest of the day. And I'm gonna sign off for now. Might be back on later, maybe playing some video games. I don't know. Enjoy the rest of your day. Thank you, and take care. Bye.